Bismillahirrahmanirrahim. Hello everyone, welcome back to the another video. So in today video we will start the another course, another book, okay, and that's you can see the front page of that book, okay. So I also I uploaded the MCQs videos, okay. If you are the engineering students and if you want to apply for different engineering jobs, okay, so for that job you will need to prepare yourself, okay. And the first step is after submitting the application, then you will need to appear for the test, okay. And in test you will see the MCQs, okay. So I uploaded different MCQs and I also uploaded the general MCQs because in every test there will be 18 to 20% MCQs related to general knowledge, okay, or Pakistan affair, current affair, different types of general MCQs, okay. So I also covered that. That's that part, okay. And the 80% is covered by the course, okay, electrical engineering course. So I also covered the Honda book, okay, few chapters of Honda book MCQs. Now in today I am going to start this book, okay, and on each day I will cover the 50 MCQs, okay, of each topic. So um, so if you have any question, you can ask me in the comment box. And if you want to find the different courses in my in my YouTube channel, then what you will do, you will need to visit my channel, okay, and then there you will find playlist, okay. So you need to click on playlist, and in playlist you will find all the different courses, okay. I also uploaded the A level physics course, okay, and also discuss the past paper of A level. And I also upload the Honda MCQs and also electrical machine different topics, okay. There you will find the electrical machine playlist, and in electrical machine playlist I uploaded the different theoretical topics, okay, where I discuss each and every topic of electrical machine in details, okay. I also uploaded the MCQs of electrical machine, MCQs of control system, okay, and I also uploaded the digital logic design different topic. So you will find lots of different courses in the playlist, okay. So let's start this book, okay. So as you see this book, in this book each chapter have lots of MCQs, okay, around about 300 to 400 MCQs in each chapter you will find in this book. So what we will do, actually I already started the Honda book chapters, okay. So in Honda book and VK Mehta book, all these chapters are present already over there, okay, and we are also discussing all these chapters. So in this book we will cover these chapters, okay, and after these chapters we will cover the we will come toward these all these chapters, okay. So on our target is to cover 50 MCQs, 50 important MCQs, okay. So in today's class we'll start the first chapter, that is semiconductor physics and diodes, okay. So in today's class we will cover the semiconductor and diode first 50 MCQs, okay. First 50 important MCQs we will cover in today's class, okay. So let's start this chapter 1, semiconductor physics and diode. So the first MCQs is, in any atom the potential energy of orbiting electron is always positive, always negative, sometime positive and sometime negative, numerically less than its kinetic energy. So the correct option is option B, that is always negative. Actually in chemistry you studied that the energy, if you want to find the energy of each orbit, so you will use this Bohr formula, okay. Bohr gave us this formula, Bohr formula, and that is your E will be equal to minus 13.6 divided by n square. N is the number of orbit, okay. So if you want to find the first shell, okay, energy of first shell, so this will be your nucleus and this will be the orbit of first shell. So for this first shell your N will be equal to 1, so the energy of this first shell will be equal to minus 13.6. So the potential energy will always be equal to, that will always be negative, okay. The next important MCQs is MCQs 4. I am leaving these MCQ because these are too easy, okay. Regarding valence band in a solid, which statement is false? So it may be empty in solids, in some solid, so that is the correct, that is the false option, okay. It is the highest occupied band, yes. It represents the energy possessed by the valence electron, yes. It is either completely filled or partially filled. So these MCQs are too easy, okay. So you can easily solve these MCQs, okay. So I am covering the important and difficult MCQs, first 50 important and difficult MCQs of this chapter. And tomorrow same I will cover the next 50 to 100 MCQs of this chapter. So the fourth MCQs is, the neighboring atoms in the crystalline lattice structure of a semiconductor like germanium form bond, that is ionic, covalent, metallic, molecular. So germanium is the group 4. Germanium is the group 4 element, okay. Germanium, silicon, okay. Sorry, silicon will come over here. So germanium, silicon, this is the group 4 element, okay. It means that the valence shell of this silicon and germanium have 4 electron, okay. So it will make covalent bond. not the ionic bond like NaCl. NaCl में कौन सा bond है? That is ionic bond. +1 -1. You already studied all these in your chemistry course. Okay. Next MCQs is MCQs number 5. Intrinsic semiconductor are those which are available locally, are made of semiconductor material in its purest form, have more electron than hole, have zero energy gap. So the correct option is have zero energy gap. In intrinsic semiconductor, it means no impurity is added in semiconductor. So if you add impurity in semiconductor, like if you add phosphorus, or if you add arsenic, or if you add indium, okay, or if you add boron in semiconductor, then that semiconductor will become extrinsic. That will be extrinsic semiconductor. You can remember it like extra, okay? You can remember this like extra. So it means some extra is added in semiconductor. So that's why this is known as extrinsic semiconductor. Okay, so the correct option will be have zero energy gap. In intrinsic semiconductor, we will have zero energy gap, okay? Okay, next important MCQs is MCQs number 8. For converting intrinsic semiconductor into N-type extrinsic semiconductor, which of the following doping elements would not be suitable? So arsenic. So as you see that in boron, this is the third group, okay? Boron, aluminum, gadolinium, indium, thallium, and group 4 is carbon, silicon, germanium, antimony, lead. Okay, this is the fifth group is nitrogen, phosphorus, arsenic. Okay, so in this case, arsenic, antimony, phosphorus, that's have 5 valence electron. Okay, so the indium is the third group element. Okay, so if you want to make the p-type extrinsic semiconductor, you will use indium. Okay, but if you want to make the n-type semiconductor, you will use arsenic, antimony, phosphorus. Okay, next MCQs is consider the energy level diagram of an intrinsic semiconductor. The Fermi level lies in the valence band, forbidden gap, conduction band. It can be any of the above location depending upon the doping concentration and temperature. So option D will not be the correct answer because here this is intrinsic semiconductor. This is not an extrinsic semiconductor. So for extrinsic semiconductor, this can be the correct option. But in intrinsic semiconductor, we will have Fermi level, okay. The Fermi level will be in between. Let's say this is the conduction band and this is the valence band. Okay, so the Fermi level will exist over here. So this will be your EF, okay, Fermi level, and that will exist in air gap. This is the air gap, okay. So that will exist in air gap. So the correct option is, yeah, you can say that will exist in forbidden gap. So the correct option is option B. Okay, next MCQ is at higher forward voltage, a junction diode is likely to burn out, get saturated, suffer breakdown, become noisy. So become noisy because this is the diode is a static device. Okay, so this will not be the correct option. Suffer breakdown, so no, this will also not the correct. And get saturated, no, this is not the transistor. Okay, transistor getting saturated, okay, or sorry, electromagnetic, that's also gets saturated. So the correct option is option A, that will burn out. Okay, next MCQ is a general purpose diode is more likely to suffer avalanche breakdown rather than Zener breakdown because its leakage current is small, no. It has strong covalent bond, no. It will not be more likely to suffer avalanche breakdown than Zener diode. It is likely to, it has low reverse resistance, so that will not be correct answer. The correct answer is option C, it is lightly doped. And Zener diode, we mostly use the Zener diode for constant voltage. Okay, if you want to get constant voltage, then you will use Zener diode. Okay, and you will connect the Zener diode in reverse form, yeah, reverse bias. Okay, the Zener diode will always be reverse biased. Okay, so the and Zener diode will also be heavy dope. Okay, it will heavily dope. Okay, okay. Next MCQs is the static VI characteristic of a junction diode can be described by the equation called Richardson-Dushman equation, Boltzmann diode equation, Einstein photoelectric equation, Child's 3-half power law. So the correct option is option B. That will be the Boltzmann diode equation. Okay, the next MCQ is the turn on voltage of a germanium diode is dash volt 0.7, 0.3. That will obviously that will be 0.3 volt, and for silicon that will be 0.7 volt. Okay, next MCQ is for converting intrinsic semiconductor into extrinsic one, the level of doping required is about 1:10⁻³ Now it will be huge. 1:1, no, this will not be equal. 1:10⁸, yes, that will be the correct answer. 1:10⁻15, no. So option C is the correct answer. You will always keep 1:10⁻15. 10 to the power 8. Okay, this will be impurity and this will be the semiconductor. Okay, so in semiconductor you will add impurity, that will become extrinsic semiconductor. Okay, the next MCQs is that is 16. The energy gap is much more in silicon than in germanium because its crystals have much stronger bond called ionic bond. No, this will have covalent bond. Its valence electrons are more tightly bound to their parent nuclei. Yes, that will be the correct option. It has high atomic mass number. No. It has less number of electrons. No. It has high atomic mass number. The atomic mass of germanium is higher than the silicon, because if you see, this is a group 4. Okay, so here you will find silicon, then here you will find germanium. So the atomic mass will be higher, okay, and than the silicon. And silicon, we have we will have a strong nuclear force. Okay, so that's why its valence electron will be more tightly bound to their parent's nuclei. Okay, so option B will be the correct answer. Okay, next MCQs is 18. Barrier potential in a PN junction is caused by thermally generated electron and holes, diffusion of majority carriers across the junction, migration of minority carriers across the junction, flow of direct current. So the correct option is diffusion of majority carriers across the junction. That is the barrier potential. Okay, barrier potential for germanium, that will be equal to 0.3 volt, and barrier potential for silicon, that's equal to 0.7 volt. Okay, and this will be unbiased. Okay, this will be unbiased. Okay, so if this is your PN junction, okay, if no voltage is applied, okay, if no voltage is applied to this junction, 0 volt, okay, then that is known as unbiased PN junction. Okay, so in unbiased PN junction, here you will get voltage. Okay, here you will get voltage, and that will be 0.7 for silicon and 0.3 for germanium. Okay, and that will be the barrier potential, and that will occur due to diffusion. Okay, diffusion of electron from here to here. Okay, so here you will get positive ions, and diffusion of hole from here to here. So here you will get negative ions. So this difference of potential will be 0.7 for silicon and 0.3 for germanium. So the correct option is option B, that is diffusion of majority carrier across the junction. Okay, next MCQs is in figure 1.1, the positive half cycle of the sinusoidal diode. Okay, positive half cycle of the sinusoidal diode, the maximum value of V naught, is, so in this case, this is the positive half cycle, so this will be plus and this will be minus. So here you will get this diode will become forward bias. Okay, so when this diode become forward bias, then the voltage across this will be equal to 0. So the correct option is option B, that is 0. Okay, next MCQs is that is 25. The peak inverse voltage is applied across a diode when it is on a heat sink, reverse biased, forward bias. So the correct option is option C, that is reverse biased. Okay, that is the peak inverse voltage. Okay, if you cross the peak inverse voltage, then the diode will burn out. Okay, so that's why you should keep in mind the peak inverse voltage when you applied the reverse voltage to diode. Okay, so the correct option will be option C. Okay, next MCQ is when biased correctly, a Zener diode act as a fixed resistance, has a constant voltage across it, has constant current pass through it, has overheat. So the correct option is option B, that is has a constant voltage across it, as I already discussed about this. Okay, 27. In order to obtain a 12 volt stabilized supply from the circuit shown in figure 1.5, the input to the terminal A and B should be less than 12 volt with terminal A positive, and with respect to terminal B impossible. Greater than 12 volt, yes, that should be greater than 12 volt with B positive and with respect to A. So if you keep this positive and this negative, then you will get, then this diode will get short circuited. So that will not be the correct option. Less than 12 volt with A negative with respect to B, no, this is not the correct option. Greater than 12 volt, yes, with A positive with respect to B. So if this is A positive, this with respect to B. So if this is positive, this is negative, then this diode will be act as an open circuit, and here you will get 12 volt. Okay, here you will get 12 volt. Greater than 12 volt, if let's say that is 14 volts, so 2 volt will drop across this resistance. Okay, next MCQ is when biased applied. Bias means voltage applied to a very capped diode. is increase, its capacitance is decrease, is increase, remain constant, first increase and then decrease. So actually the first, what is mean by varicave diode? So varicave diode is nothing, it is just like the varactor diode. Varactor diode means that will have different capacitance, like you can increase or decrease the capacitance, okay, by increasing the area, by using different permittivity material between the plates, by increasing or decreasing the distance, okay, between p-type semiconductor and n-type semiconductor. So in this case the question is when bias applied, so it means we need to find the relation between voltage and current, capacitance. So as we know that current is equal to C dV by dt, and your voltage VC, that will be equal to 1 divided by C into IC dt. Okay, so here you can see that the VC is inversely proportional to C. So if you increase this, then the capacitance should be decreased. When bias applied to a varicave diode is increased, its capacitance is decreased. So option A will be the correct answer. Okay, next MCQs is a light emitting diode, that means LED. A light emitting diode can be made from phosphorus material, germanium, silicon, gallium arsenide. So that should be made from gallium arsenide. Okay, so this will be the correct answer. Okay, next MCQs is in figure 1.6 with S1 closed and S2 open, S1 closed and S2 open, the lamp glows dim. When S2 is also closed, it glows brightly. It indicates that D is good, bad, shorted, maybe good or bad. So this MCQs need a little bit explanation. Okay, so here we have this this switch is closed. Okay, this switch will always be closed, and now depend on this switch. Okay, when you close this switch, then this lamp will glow brightly. Okay, but when you open this switch, then this lamp will glow dim. Okay, so what is the reason behind this? So when this switch is open, then the current will flow like this. Okay, and this is AC because frequency is given to me, so that means this voltage is AC. So current will flow like this. Okay, and it will come like this for the positive half cycle. For positive half cycle, this will go like this. This diode will get short circuited and it will come like this. But for negative half cycle, this diode will act as a reverse bias. So the resultant voltage across this bulb will be like this, then this, then this, then this. So that will be half wave. Okay, that will be half wave. Okay, so and we know that the half wave RMS value is half wave. We have half wave and full wave. So the half wave RMS value, we have full wave and we also have sinusoidal. So we know that the sinusoidal RMS value of sinusoidal is 0.7, okay, and the RMS value of half wave is 0.5 volt, okay, and the RMS value of full wave is also 0.7. So if you take the average value of this sinusoidal, that should be equal to 0, okay, so that's why we use RMS for AC. So here you will get the less RMS value, okay, or less average value, okay, so that's why this lamp will go dim, will glow dim, okay, but when you close this switch, okay, then sinusoidal voltage will appear across this, okay, and the RMS value of sinusoidal voltage is 0.7 volt, okay, so that is greater than 0.5 volt, so the lamp will glow brightly. Okay, so it means that the diode is good. So in this way you can check the diode, okay, the condition of the diode. Okay, next MCQ is a photo tube is an electronic tube whose resistance decreases as its cathode is exposed to more light. That's emit photoelectron when its cathode is illuminated. Yes, so if you illuminate the cathode, okay, this is anode, this is cathode. So this will be your photo tube, okay. This will be a vacuum pump, okay. Okay, so here you will have anode and here you will have cathode. Okay, so light will come like this on cathode. So this plate will emit electron and that will move like this. So here this will be positive, so this will attract this electron and that will move like this, okay, in the external circuit. So if the intensity of this light is high, then more electron will get emitted, okay. So that's emit photoelectron when its cathode is illuminated, okay. So if a cathode is illuminated, not the anode, so the correct option will be option B. Next MCQ is, in figure 1.7, which component is the battery charging circuit is wrongly connected? Battery control resistor, rectifier diode, transformer. So this is the bridge, Wheatstone bridge. So you should need to understand that how you will connect the diodes in Wheatstone bridge. So here, this is the Wheatstone bridge. Okay, so let's draw it. So this is the book diagram. This will be the output. So what will happen when current come like this? Okay, if this is positive, this is negative, current will come like this. It will come like this. Then it will go like this. No, this is wrong. We will need to connect it like this, so that current will not flow like this. So current will come like this, like this, like this, like this, like, and this should be like this. Okay, so it will not come, it will not flow in this direction because the potential is same. Okay, this is positive potential, so it will not flow like this. It will come like this, like this. Okay, so in this case, in this way, the circuit will get completed. So or you can change these diode. Okay, so that will be the correct option is rectifying diodes. Okay, due to wrongly connected rectifying diode. Battery is okay, control resistor is okay, transformer is also okay. Correct option will be option C. Okay, next MCQ is, for converting a piece of pure silicon into a p-type extrinsic semiconductor, you will add an extremely small quantity of boron. Okay, that is group 3 element. The valence electron of boron is 3. The maximum reverse voltage that can be applied to an ordinary semiconductor diode without irreversible damage is called peak inverse voltage. I already discussed about this, and you should need to know about the peak inverse voltage of diode. Okay, addition of impurity in the ratio of 1 and 10 to the power 8, we already discussed this in one of the last MCQs. To a pure or extrinsic semiconductor, decrease its conductivity near 100 times. No, impossible. Increase its conductivity near 10 to the power 8 times. No, that's too huge. Increase its conductivity nearly 100 times. Yeah, that is the correct option. Increase its resistivity. No, that's not possible. So the correct option is option C. Okay, next MCQ is, in a p-type semiconductor, free electron form majority carrier, take no part in conduction, equal the number of hole, form minority carrier. In p-type semiconductor, the free electron is in the minority carrier, is the minority carrier of p-type semiconductor. So that will form minority carrier, and hole is the minority carrier in n-type semiconductor. Okay, next MCQ is, in an unbiased, it means no voltage is applied across p-n junction. The thickness of the depletion layer is of the order of 0.5 micrometer. That should be the correct answer. That's not too small. 5 micrometer, no. 10 to the power minus 10 meter, no. That will be the 0.5 micrometer. Option B will be the correct answer. Okay, next MCQ is, a tunnel diode has a small tunnel in its junction. No. Is a point contact diode with a high reverse resistance? No. Is a gallium arsenide diode, that is the LED, I already discussed in one of the last MCQs, is a highly doped p-n junction diode. So that will be the correct answer. So due to highly doped p-n junction, it is about 10 nanometer wide. Okay, tunnel diode is about 10 nanometer wide. Okay, next MCQ is 40, a step recovery diode. So first we need to understand that what is step recovery diode. Step recovery diode. So step recovery diode is used to generate an extremely small pulse. Okay, step recovery diode is used to generate extremely small pulse. Also called it as a snap off diode, or you can say that it is charge storage diode, or it is also known as memory varactor. Okay, and the symbol of this diode is like this. So this will be the symbol of this varactor diode. Step recovery diode. Okay, it is also known as snap off diode, charge storage diode, memory vector. Okay. So the step recovery diode has an extremely short recovery time. No, conduct equally well in both directions. No, so that will not be a diode. That will become short circuited. It's mainly used as a harmonic generator. Yeah, that is used to generate small pulse. Okay, so that will be used as a harmonic generator. Harmonics means multiple frequency signal. Is an ideal rectifier of high frequency signal. No, so option C will be the correct answer. Okay, these MCQs is too easy, so you can easily solve all these MCQs. Okay. Uh, MCQ number 47. Referring to the charge level diagram of semiconductor material, the width of forbidden gap is about 10 electron volt. No, this is too huge. About 100 electron volt. That is also too huge. About 0.1 mil electron volt. No, that is too small. That's about 1 electron volt. That should be the correct answer. So option C is the correct answer. Okay, next MCQ is a p-type semiconductor material as a whole is positive charge. No. Negative charge. No. This is electrical neutral. Okay, you should remember this. P-type semiconductor is electrically neutral because here we have holes. Okay, we have huge number of holes, so that's why it is called p-type semiconductor. But we also have ions, negative charge ions, so that's why as a whole this is electrical neutral. Okay, and similarly n-type semiconductor is also electrical neutral. In this type we have huge number of electrons, but we have huge number of positive ions, so that's why this is also electrical neutral. Okay, the last MCQs of this video is one of the following statements justify the extensive use of semiconductor material. It is because of their low forbidden energy gap. No, it is not necessary. It depends on the material. It is because of their resistance value which lies between that of good conductor and insulator. No, this is not a huge point due to which we extensively use semiconductor. It is because of ease of fabrication of semiconductor material into practical active and passive device. No, this is also not the correct answer. It is because of the fact that there is having some wide-ranging characteristic when certain specific impurities are added to the in control amount. Yeah, so that will be the correct answer. Option D will be the correct answer. So due to this option, we use the extensive use of semiconductor material. Okay. So this statement will justify the extensive use of semiconductor. It is because of the facts that they exhibit some wide-ranging characteristics when certain specific impurities are added to them in controlled amount. So this will be the end of this video. Okay, if you want to find the other courses, okay, other courses like Honda, electrical machine, control system, DLD, okay, signal and system, okay, maths, A-level physics past paper, okay. So you just need to visit my channel. Okay, there you will need to click on playlist. Okay, so in playlist you will find all these courses. Thanks for watching. See you in next tutorial. Allah Hafiz.